that probably take.
Hey, what's going on, guys? I have a new video for you, Unit 9 test review. Hey, make sure you use this resource to study, practice, and more practice. And bring me gobs and gobs of questions. Let's prepare for this test. I'm actually going to move it back to Friday. Friday the 16th, 17th, 18th, Friday the 18th. We're going to have this test. I moved it. So Friday, I will see you excel on this test. All right. So, hey, happy studying, and let's get started. All right. So graph each function and identify its domain, range, transformations, and behaviors and zeros. All right. All this is just a review from what we've been doing this week, guys. So let's go ahead and dig in. First, we need to graph it, of course. And when we graph it, we're going to get the following points. Of course, 0, 4, because it moved up 4. All right. And then we're going to get 1, 3, 4, 2. And let's see, 9, 1. 9, 1. All right. So our graph looks something like, oh, man, I'm way off the mark. Let's start over. Man. All right. A little better. Now, let's talk about the transformations. Well, that negative tells me it reflects the x-axis, and then that plus 4 tells me up 4. Okay, up 4. Now, domain. Well, remember, this starting point is 0, 4. So the domain, since it's going to the right, all the x values are getting larger, 3, 6, 9, and so on, so on, and so forth. So x is greater than or equal to 0. For the range, the y values are decreasing, 4, 2, 0, negative 2, negative 4. They're getting smaller, so we say y is less than or equal to 4. For the end behavior, all right, as x goes to the right, where's the graph going? Well, f of x tells us y value. So think y. Where are the y values approaching? They're going way down infinitely. They keep going down to negative infinity. So that's what we say. As x goes to the right, the function goes to negative infinity. As s goes to the left, all right, where does the y value go? As I go to the left, well, I can't go past this point. The y value is 4, so I can only go to 4. The zeros, if I put it in my calculator, I end up with the point 16, 0, so x equals 16. And I got that from my table, guys. I just scroll down. But you can also use the second trace, left bound, right bound, and then guess, and it'll get you a 16, 0. Now, increasing and decreasing. Well, if you look at this graph, it's going down. So we see that because it's going down, it's definitely a decrease. So there's no increase. Excuse me. With it being no increase, we just got to define the decrease. So we start right here at 0, because that's where it starts, at x is 0, and it decreases, all right, to positive infinity. It will never stop decreasing, okay? It decreases forever to the right. So we say 0, to positive infinity. All right. Now, moving along, we now have the cube root of x plus 1. All right, so hopefully you know how to put that in your calculator. All right, but we have cube root of x plus 1. All right, all underneath the parenthesis. So we graph that. And then we need to find some points that we want to use. So look at your table on your calculator. All right, and some of the points I see, like I have 7, 2, 7 up 2. Oh. Let's grab. Come on. Let's pick another color. Let's go with a green. 7, 2. And let's see, what else do I see here? 0, 1. So 0 up 1. And then I have negative 1, 0. That's also our root. That's our 0 right there. All right. And negative 2, negative 1. And let's see if there's anything way to the left. Yep, negative 9, negative 2. So we have this sketch right here. All right, this is just a sketch. I wish I could draw, man. Gosh, my hand is shaking. Anyway, transformations. Well, we only have, guys, make sure you know that this is the cube root. That's the index of the radical. That is not a transformation. So the only transformation we have is that +1, which we would say left 1. All right. Now, domain. What's the domain? Well, it's cubic. It's cube root. So it's going to be all real numbers. The range is as well, all real numbers. Now, as S goes to the right, as S goes this way, where's the function going? Where's Y going? It's going up. So we say to positive infinity. The Y's will continue up infinitely. As S goes to the left, where's the graph going? It's going down. All right, it will continue negatively. All right, so we say negative infinity. The zeros, we can see it just right here. X equals -1. This graph, again, you read it from left to right, and we see that this is increasing. I know mine has a dip. It's not a dip there, man. I just can't draw. All right, this thing actually continues infinitely on an increase. Man, that's better than the last one. It continues up, it increases, so there's no decrease. And because it's all real numbers, we can say from negative infinity to positive infinity, like that. Now, let's move over to the last one. Oops. All right. Right here, let's go ahead and graph that. We have Y equals 3 times the cube root of X plus 2. Close the parentheses if you got them. And then -1. All right, make sure you understand that the index there is a 2. All right, this 3 is not the index. All right, 2 is the index. So, did I say the cube root? I meant the square root. I'm tripping. All right, now this is a square root. Now, when we graph it, all right, we know left 2, down 1. So 1, 2, down 1. There's 1 point right there. Look at your graph. Let's see if we can get some more. A -2, -1. We have -1, 2. Man, that stretch is really pushing it. We have 2, 5. So 1, 2, up 5. And let's see if we can find one more. 7, 8. Cool. 7, up 8, like that. So there's our graph. Like that. All right. And that point again was -2, -1. Now the transformations. Well, we have a vertical stretch by 3. The 3 out front. We went left 2, and then down 1. All right, down 1. So there's your transformations. Now domain is going to the right. The function is going to the right. So we say that X is greater than or equal to our X value, which is -2. And for the range, it's going up. So we say Y is greater than our Y value of -1. Greater than or equal to -1, excuse me. For the end behavior, as S goes to the right, as I go this way, where is that function going? It's going up. So we say to positive infinity. And as S goes to the left, all right, as it goes to the left, well, look at this line. How low can the actual function go? And that's -1. It can only go down to -1. Remember, f of X is your Y values. Now for the 0, all right, for the 0, you can put that in your calculator, second trace, left bound, right bound. I'm sorry, 0 first. Just that left bound, right bound, and guess, and you get -1.89. All right. And then clearly this is the increase from left to right. I am going up, so there is no decrease. And we say the increase is from -2 to positive infinity. Now, let's move down here. Now we're going to look at the transformations. I'm going to zoom in so I can have more space to type. Now, with these problems, the first thing you need to do, see how this is -3 times this parenthesis X plus 2. Well, let's go ahead and distribute that. And what we get is -3 times, I'm sorry, not -3, it's in the parenthesis. we get negative times the square root of negative 3 times x is negative 3x. And negative 3 times 2 is going to be minus 6. Negative 3x minus 6. So now we're going to write our transformations in. I just said type because I need to type so I can have some space. And it'll be a little more neater. Alright. I don't know why my mouse isn't working, but here we go. So here we go. The negative out front tells us it reflects the x-axis. Alright. The negative right here tells me reflects the y-axis. Actually, let me make all this a little smaller because it's kind of big. Alright. The 3 right here, remember, use the reciprocal. So that means we have a horizontal compression, or you can say shrink, depends on your teacher, by a factor of 1/3. The reciprocal is 1/3. Since it's 1/3, we have a shrink. All right, it's a fraction, so it's going to get smaller. Okay, think about multiplying the number to a fraction, it will get smaller. Like 1 times a half will be half, right? Got smaller. And then this minus 6 right here. All right, this minus 6 tells us right 6 units. Okay. Now, let's look at our next example. And again, for this one, if you see, there's another fraction times a set of parentheses. So we're going to distribute that 1/5. So we have 5 times the cube root. Hey, make sure you know that this is the cube root. That's not 5 cubed. Okay, it's not 125. That's 5 times the cube root. So 1/5 times x is 1/5 x. And then 1/5 times 5 is actually 1. And then we have minus 7 outside of that. All right, so now I'm going to type from there. Let me minimize that size. Okay. Now, that 5 out front, that 5 tells me we have a vertical stretch by 5. And then the 1/5 right here, remember, use the reciprocal. Just like over here we had 3x and we used the reciprocal and got 1/3. But right here we have 1/5, so reciprocal would be 5. So that's going to be a horizontal stretch by 5. And then we have the minus 1. So let's go left 1. Plus 1. Plus 1, so we have left 1. And then we have minus 7 on the outside, so we will go down 7 units, okay? All right, and then for this one, there's not much to type. All right, that 8 tells us right 8, and that plus 9 tells us up 9. So that one's simple. All right, so there's our transformations, guys. Now let's jump down to number 10. Number 10 says the parent function, the square root of x is reflected across the x-axis and then is translated 2 units right and 3 units down. And is there more? Oh, write the function. So I'm going to call it g of x since f of x is square root of x. So I'm going to go g of x since it's a transformed function. So we have across the x-axis means negative out front. Translated 2 units right means x minus 2. That's to the right 2 units, and then down 3. All right, down 3. So that will be our function for number 10. Hey, I'm gonna actually stop right here, guys. Reason being is because this is getting kind of long. It's longer than I want. I always want to keep it under 20 minutes, so I want to go over it. I want to start a part 2 video And I should be able to get the rest done in part 2. So, hey, I hope this helps. Tune in for the next part, and I will catch you later.